class. I hope you are having a nice time. I hope all the notes that we have uploaded in the portal, I think you are having time to read the notes. This is chemistry class, and we are going to start with revision on oxidation and reduction. Oxidation and reduction. If you look at this definition, you will see that oxidation is the addition of oxygen to a substance, while reduction is the removal of oxygen from a substance. It can also be said to be loss of electron, that is oxidation, while reduction is gain of electron. There are some examples to buttress this fact that oxidation is addition of oxygen and reduction is removal of oxygen. If you look at this equation very well, you will see that I have magnesium and oxygen. When you see that oxygen is added to magnesium, you will see that it gives us magnesium oxide. That is, we have added oxygen to magnesium. When you look at B, we have copper 2 oxide plus hydrogen to give us copper plus water. When you look at this equation very well, this CuO, we have removed oxygen from CuO and we now added it to hydrogen. That is, oxygen has been removed from CuO and hydrogen is added to it. So that is reduction. Don't forget, oxidation, addition of oxygen to a substance, and reduction, the removal of oxygen from a substance. Let's go to the loss of electron and the gain of electron. That is according to the definition. Look at this zinc 2+, zinc ion. It has gained 2 electrons to give us a zinc. If you look at this, you will see that this equation, zinc 2+, it is from 2+ then to an element in its free state. This element in its free state, we normally assign oxidation number of 0. That means from +2 to 0. That is decrease in valency. And when there is decrease in valency, it's going to be a reduction. That means electron is gained by zinc ion, causing a decrease in its oxidation number from +2 to 0. When you look at this, D, copper and lost 2 electrons to give us copper 2+. This is oxidation. That means electron is lost by copper, causing an increase in oxidation number of 0. Element in its free state is 0 to +2. That means there is an increase in oxidation number. And don't forget, oxidation is an increase in oxidation number, while reduction is a decrease in oxidation number from +2 to 0. This one from +0 to +2. Now, let's go to oxidizing and reducing agents. Oxidizing agents are substances which bring about oxidation by the addition of oxygen to any substance, while reducing agents are substances which bring about reduction by the removal of oxygen from the substance. You may not understand this thing until you see this flow chart. I call it flow chart. If you look at this, let's look at this equation: CO plus H2 to give us Cu plus H2O. If you look at this CuO is an oxidizing agent, because when you look at it, it is from +2 to give us 0. That means oxidizing agent is a substance that has undergone reduction. That means from +2 to 0. When you look at this hydrogen we assign oxidation number of 0. Then when you now look water here, you will see that this oxidation number will be 1. That is, when you want to find the oxidation number of hydrogen in water, it's going to be 1. That means from 0 to +1. Just take a look. H2O, that means let me assign 2x plus minus 2 equals to 0. So 2x minus 2 equals 0. So 2x is 2. X is 1. So that means from 0 to plus 1. This one from plus 2 to 0. So CO is oxidizing agent because it has undergone reduction, while H2 is reducing agent because it has undergone oxidation. I hope you are following me. Now, let's go to the last part of our revision for today, which is redox reaction. What is redox reaction? Is a reaction in which both oxidation and reduction takes place simultaneously. Now, one thing that is more important in redox reaction is balancing of redox reaction. How do we balance? If you look at this very well, this equation, we have tetraoxomanganese 7 ion plus iodide ion to give us iodine to give us manganese 2 plus. Look at step 1. This MnO4 will match with Mn2 plus. Why is this reduction? When you find the oxidation number of manganese here, you will see it is from plus 7 to plus 2 manganese. That is why it is reduction. When you look at this iodide ion, this one is from minus 1 because this minus sign is minus 1 to a 0 element in its free state. That means oxidation minus 1 to 0 increase, plus 7 to plus 2 reduction decrease. Now step 2, we are now going to add hydrogen ion to the reactant, and we are going to add water to the product. That means we are going to have hydrogen ion at the left hand side, water at the right hand side. If you look at this, you will see that we have 4 molecules of oxygen. We have 4 molecules of oxygen. If you look at here, we have 8 hydrogen. That is why we must add hydrogen ion here, and that is why I got my 8 hydrogen. That is step 2. Then step 2, we also have another one is 2I. We want to make it to be balanced. 2I to be I2. Take note. This is 2I. We have 2 molecules of iodine and we have 2 molecules of iodine. That means it is balanced. That means this is a balanced equation. Look at step 3 now. We now want to remove, we want to make sure that the number of charges are equal. This one is MnO4. MnO4 minus plus 8H plus to give us plus 5 electron to give us Mn2 plus 4H2O. If you look at it, this one is minus 1 plus 8 plus 5, and this one is plus 2. That means minus 1 plus 8 is 7. This one should be minus 5 because of this 5 electrons minus plus plus is minus, so it's going to be 7 minus 5, which is 2. That means you have a balance charge of plus 2 at each charge. That is why you see 5 electrons here. So plus 5 is the one that we added to make sure that all our redox equation is balanced. So this one we have 2I minus here to give us I2 plus 2 electron. When you look at this one is minus 2 at the left hand side, and this one is 0 before. So how many, which figure are you going to add to 0 to give you minus 2? That is why you must add 2 electron. So 0 plus 2 electron minus, don't forget it's minus 2. So plus plus minus is minus. That's why we have 2 electron here. So, and that is why we have this equation. So step 4, we now multiply this equation by 2 and 5 to balance and cancel. We want to cancel out this electron. That is why this equation 1, we must multiply it by 2. If we multiply it by 2, it's going to be 2 MnO4 minus plus 16H plus 10 electron. When you multiply this one by 2 to give us 2 MnO2 plus H2O. Equation 2 here, 2I minus to give us I2 plus 2 electron. When you multiply it by 5, we are going to get 10 electron to give us 5 iodine plus 10 electron. Now let us cancel the electron. That means we have to join this equation together, the reactant and the product. They must be at the same line. 2MnO4 plus this, that is this, plus 10 iodide ion to give us this. That is why it is at the product side. 10 electrons cancel 10 electron. So the equation will now become 2MnO4 minus plus 16H plus 10 iodide ion to give us 2N2 plus 8 molecules of water plus 5 iodine molecule. If you look at this now, that means we have cancelled out the electron. We now want to check whether this equation is a balanced redox equation. When you look at this, that means we must check from here. This one is minus 1 times 2. That's how I got my minus 2. We want to check the number of charges. Plus 1 times 16. That's why it is plus 16. This one is minus times plus. Minus times 10. That's minus 10. And when you look at this one, to the product side, this is 2 times 2, 4. This one doesn't contain any ion, so they are free state. We normally assign is 0, is 0. So when you now look at this equation very well, you will see that our equation has balanced charges of plus 4 each. That means you have plus 4 at the reactant and plus 4 at the product. Then when you now look at it, whether they are balanced, 2 manganese, 2 manganese. Oxygen here is 8. 2 times 4, 8. 8 oxygen. Let's look at hydrogen. We have 16 here. 8 times 2, 16. Let's look at iodine. We have 10 here. 5 times 2, 10. So this is an example of a balanced redox reaction. I hope with this explanation you're able to know how to balance redox reaction. This is where we are going to draw our curtains on today's class. So if you have any comments, contribution, question, you can forward it to my personal WhatsApp number. I'll be ready to entertain your question. Thank you and God bless.